Our computer lab technicians repair a wide variety of industrial computers, monitors, printers, and human-machine interface devices from many manufacturers. Many of these devices are on the verge of or have already become obsolete or are no longer supported by the OEM. With today's technological advances, it is a must for our technicians to have the ability to think outside the box. Doing so has led to a development that has given new life to obsolete industrial monitors and HMI workstations designed around CRT deflection assemblies. Our technicians have developed what we call an LCD conversion to replace the CRT deflection assembly of obsolete systems. Analog deflection circuits and CRT components are removed. The unit is then re-engineered with new LCD digital technology. This is done without compromising original functional specifications. The unit operates exactly as it did originally. In some cases, other features are added, such as a remote control to adjust the picture characteristics of the display while standing in front of the unit. An LCD conversion is a low-cost solution with great benefits that are passed on directly to our customers. Power consumption is reduced by approximately 2/3, weight is reduced by more than half, and the service life is increased by many years. An LCD conversion effectively bridges the gap between older technologies and the new. This could mean the difference between keeping a line of equipment running or expensive replacement to accommodate new monitoring technology. This is the General Repair Laboratory. The technicians in this lab process a large variety of items that do not fit the repair profile of our other electronic repair labs. Some of these systems include the SICK PLS units, light curtains, temperature controllers, power supplies, and individual plug-in cards for various rack and drive systems. A key feature of the General Repair Lab is a light curtain tester created by our engineering staff. It allows us to test a wide variety of light curtains and controls. Another key feature of the General Repair Lab is a system called Pinpoint. This is a computerized analysis of assemblies containing large quantities of integrated logic chips. Pinpoint will learn the integrated circuit components of a circuit board, test them individually, alerting the operator of any individual chips that have failed. Having a Pinpoint system in place provides this lab with the advantages of greater accuracy, faster problem diagnosis. This system will also assist in the final testing to ensure reliable repairs are being returned to our customers. We are now in the mechanical repair area. As you can see, we have a number of servo motors here waiting to be repaired. These servo motors are a natural outgrowth of our electronic repair capability because they have electronic devices attached to them. In this department, the typical technician will be responsible for the repair of this motor from beginning to end. Our servo motor repair specialist can repair, refurbish, and rebuild most AC servo motors, DC servo motors, stepper motors, pancake-style motors, brushless DC motors, spindle motors, tachometers, encoders, and resolvers. Some of the manufacturers include ABB, Allen Bradley, Fanuc, Sanyo Denki, Nachi, Panasonic, Reliance, Yaskawa, Siemens, and more. To ensure our servo motor repair process remains consistent, ICR has invested in a wide variety of testing systems. Some were designed by our in-house engineers. These systems help us to quickly diagnose most servo motor and feedback problems. These same systems are used after repair to certify a motor is working properly before it is connected to a control system for final testing. I just walked into the ICR Machining Center. In this area, we do all the machining required to support the mechanical repairs that we do on servo motors, robot wrists, and other mechanical type devices. This area was set up about a year ago because we wanted to bring in the outside labor that we used to use to do machining in-house to better serve our customers. As you can see from the boxes in the foreground, we've arrived at the ICR shipping department. The gentlemen behind me are in the process of returning the products that we have repaired to our customers. As you can see, the package being put in the bottom of the box, that is a container of foam composite which will foam up around the part to protect it during shipment back to our customers. That way we can make sure that the products that we've repaired here arrive back to the customers in a good repaired condition that it left our building. All of our repairs are packed in either an anti-static wrap or an anti-static bag to make sure there's no static damage to them in the return process. We're now in the classroom of the ICR Learning Institute. Early on, we talked about the ICR Learning Institute as being one of our new core competencies. In this room, I just want to take a minute to show you the types of training that we can do. Now, we offer two types of training. We have corporate training for our corporate customers, where we show them how to program robots or program PLCs. We also offer training to people that have lost their jobs or students that are looking for an occupation in life. They can be trained to be PLC programmers or robot programmers. As I said, this is a typical classroom. Behind me is a typical workstation. We have the PLCs, We have inputs and outputs. We have the different types of devices that are used in industry to program the PLC. What we do here is we will set down a number of students and they will work with the professor. They will learn how to program the PLC, they will simulate the inputs and see the resulting outputs. This is all part of the learning process for them to learn how to be a PLC programmer. An additional offering of the ICR Learning Institute is the programming and maintenance of robots. In this environment, our students, be they be corporate or students that want to learn a new occupation, are taught how to program robots, how to maintain robots, also how to do preventive maintenance on robots. In this area, you can see we have a typical work cell set up with the robot that's been programmed and taught how to make various shapes. This would be typical of a sealant type application. We also see it working on a conveyor belt back there. We also have the ability to hook up a welding torch and things of this nature. So we can actually teach our students, in addition to how to program the robot, troubleshoot the robot, maintain the robot, we can also teach them how it acts and how it lives in a cell type environment that they will see in the industry. We are set up in here to handle Motoman, FANUC, and also ABB. These are the typical type robots we train on. However, there are many other manufacturers and all of those robots can be brought in and we can offer the same type of training on all of them. Industrial Control Repair's vision is to be recognized in the industry as the most valued industrial service and solutions provider. Our mission is to provide cost-effective solutions to our customers' needs ethically, reliably, and responsibly. In order to meet these vision and mission statements, we found it necessary to embark on a lean enterprise strategy. A lean enterprise strategy is a method of continuous improvement that eliminates waste and continually improves our processes and our business. One of the initial steps in that process, or in the lean strategy, is to develop a value stream map. The value stream map is a current state of our processes and how they intermingle with one another. The next thing we did was take each of those processes and establish goals and objectives for those processes. Those goals and objectives